Good afternoon, students. So in the last class, we discussed about public key crypto system. The introduction part of the public key crypto system. Public key crypto system is nothing but is a asymmetric key, isn't it? It is a asymmetric key crypto system. A sender and receiver. So sender will have two keys. Both the parties, like a sender will have two keys as well as a receiver will have two keys. So there will be a private key as well as the public key of a user. So public key will be so both the private and public keys will be stored in a repository, and the public key will be accessed by everyone over the network, whereas the private key can be used only by the user. Either it may be, if it belongs to the sender, only sender can use its private key. If the private key is generated by the receiver, then only the receiver can use that particular private key. That is the public key crypto system. So which was developed after this symmetric key crypto system. So one of the algorithms of public key is RSA. RSA algorithm. So it was developed by Ron Rivest, Shamir and Edelman. So these three person names commonly has given the name as RSA algorithm at MIT University. And here, so many of the public key algorithms uses the prime numbers concept or some mathematical functions like modulo arithmetic and some prime numbers and GCD. So all these concepts will be used in public key algorithms. So here in RSA, so how, so RSA, like some algorithms in public key crypto system are used to convert the plain text to ciphertext, like for encryption or decryption purpose, and some algorithms are used for key exchange. Okay, some algorithms will be used for key exchange, like for symmetric algorithms, same key will be used at the sender and receiver side, right? So there's that key, in order to encrypt that key and to transmit the key, so some algorithms will be used. So the algorithms are the public key algorithms. And also, so when sender is sending some document, instead of converting the entire plain text into the ciphertext, some only one particular block of data will be converted to the ciphertext. So that will be attached to the entire document. That is called as the digital signature. So in all these three cases, the public key algorithms will be used. So RSA will be used for all these things, encryption, decryption, and for digital signatures as well as for key exchange. So whatever the purpose, so the procedure of RSA, how it is going to convert the message is, so first it chooses the plain text. So if capital M is the plain text, and it chooses a value n. So initially communication will be happening between two persons, like Alice and Bob, isn't it? So Alice and Bob. So if Alice wants to send a message to Bob, okay, Alice wants to send a message to Bob. So what Bob has to do is, first Bob has to create its a public key as well as a private key. Okay, so private key will be represented with KR. So Bob's private key will be represented with KRP, and Bob's public key will be represented with KUB. Like that, Alice will also have the keys. So first of all, if Alice wants to send message to Bob, so Bob has to create the public and private keys. Okay. For that, so what Bob will do is, so there will be some procedure. That is, first Bob has to choose some two prime numbers. Okay, so Bob has to choose two prime numbers. Bob has to select two prime numbers, like P and Q are the prime numbers. So after selecting the prime numbers, Bob has to calculate the product of these two prime numbers. That is, n is the product will be represented with n. So n is equals to P into Q. So after selecting that, Bob has to apply the Euler-Stoichhian function or Euler's pi function. That is, pi of n is equals to P minus 1 into Q minus 1. An integer. Okay, Bob has to select an integer. So an integer value, that is E. Integer is E. So where it has to satisfy the condition, that is GCD of E comma pi of n is equals to 1. Okay, Bob has to select one integer E. So where that GCD of E and pi of n. So pi of n is already calculated at step 3, right? So pi of n, GCD of E comma pi of n is equals to 1, in such a way that the Bob has to select E. And then the fifth step is Bob has to Bob has to calculate the D value, D. So such that E into D is congruently equivalent to 1 mod phi n. 1 mod phi n. So this is the procedure should be done at Bob's side, because Alice wants to send message to Bob. So if Alice wants to send the message, Alice will encrypt the message using the Bob's public key. Okay, using Bob's public key means Bob has to create the public key. So as well as the private key. Why? Because so once Bob received the message from Alice, Bob has to decrypt the message. So that is why Bob has to create both public and private keys. So in order to create public and private keys, so first step is Bob has to choose two prime numbers. P and Q are the prime numbers. Then calculate the product of prime numbers, and the result will be stored in n, variable n. And the third step, Bob should calculate phi of n, where pi of n is equals to P minus 1 into Q minus 1. And the fourth step is Bob should select an integer E. Okay, an integer E. So E is nothing but some public key. Okay, E is always a public key and small d is a private key. Okay, so whatever the value is selected, so that should satisfy the condition GCD of E comma pi of n is equals to 1. In that manner, Bob has to select E. Then Bob has to find out the D. So that is E into D is congruently equivalent to 1 mod phi n. So it should satisfy this condition. In that manner, Bob has to select this E and E value. So based on the E value, we can easily calculate the D value, isn't it? So this is the procedure. So this procedure should be done at Bob's side. Okay, done at Bob's side. So once this is done, then among all these values, so here it has totally how many values? So initially P and Q are there, and then from P and Q it is Bob is calculating n value, that is n is equals to P into Q. Then Bob is selecting E, and then D value will be calculated. So total 5 values. So these 5 values belongs to the key space or key. So the entire key of RSA consists of all these 5 values like P, Q, N, E, D. In this, so ED is congruently equivalent to 1 mod phi of n. So it should satisfy this condition. whatever the values we are going to select. So either P, Q or E. So it should satisfy E into D is congruently equivalent to 1 mod N. And among all these values, in public key crypto system, it uses two keys. One is private and the other one is a public. So among all these 5 values, P, Q, N, E, D, N and E are the public values. N and E are public, and P, comma, Q and D are the private. Okay, so these 3 are private because Bob is choosing the prime numbers P and Q. Bob is choosing prime numbers P and Q. It will not be public. Means Bob will not announce that the prime numbers whichever has chosen by the Bob. Okay, so P and Q are the private values and D also private. Whereas E is the public value. E and N. So N is the product. So product of the product of the prime numbers. So once Bob chooses the values, what the Bob will do is, so Alice and Bob, the communication will be happened. So first Bob will send the public key. Okay, Bob will send the public key, that is E. E is the public key. B subscript B means it is the Bob's public key. Okay, Bob's public key will be forwarded to the Alice. Then Alice will send the ciphertext. Alice will send the ciphertext. Then how the Alice will send the ciphertext is, first of all, Alice has to choose some message. Suppose M is the message, then the value of M is less than N. So what is N? N is nothing but product of 2 prime numbers. Whatever the value is there. So always the plain text message M value should be less than N. That is M belongs to the Z category, Zn. Okay, M belongs to Zn, modulo representation. So M belongs to Zn, that is 0 to N minus 1. Okay, 0 to N minus 1. And also Bob has to select a message, Alice, what are the message selected by the Alice. So that message, the GCD of M comma N will be 1. Okay, GCD of M comma N will be 1. And then, so how the Bob is going to, how Alice is going to encrypt the message. So in order to encrypt the message, so Alice will take the message and applies the encryption algorithm using the Bob's public key. Okay, using Bob's public key. Then here it will be done by applying this formula M power E mod N. So where N and E are the public values, isn't it? So here it is going to generate the ciphertext. So ciphertext C is equals to M power E mod N. So what is M? M is the plain text. M is the plain text. N is the product of prime numbers P and Q. And E is a number. So which is selected by the, we can say that E is the public key which is selected by the Bob. Okay, so first E is shared with Alice, isn't it? So by using that E value, Alice will encrypt the message. So this is the encryption procedure. And once Alice encrypted the message, now Bob has to decrypt the message. So to decrypt the message, so what Bob will receive the Bob will receive the ciphertext. So Bob will apply the decryption algorithm. How Bob is going to decrypt the message? Using Bob's private key. So private key will be represented with a small d. Okay, small d. So here by decrypting, Bob will get the original message. So to decrypt this, Bob will use the Bob's private key. So the formula is C power D mod N. C power D mod N, where D is the private key of Bob. Okay, so for encryption, Bob's public key is used, and for decryption, Bob's private key will be used. So this is the decryption. This is the formula for decryption. Understood? So the formula for encryption is C is equals to M power E mod n, and formula for decryption is M is equals to C power D mod n. C is equals to M power E mod n. This is for encryption. And M is equals to C power D mod n. This is for decryption. Decryption, isn't it? So if we rewrite, C is nothing but M power E mod n, isn't it? C is nothing but M power E mod n. So if we rewrite, we'll get this M is equals to M power E D mod n. Okay, so just now we discussed both sender and receiver will know N, means N is a public. So sender knows the value of E, that is public key of the receiver. Only receiver knows the value of P. D is the public key. Suppose if you observe KU means it is a public. E and N are the public keys and the private key is D. Okay, so the steps required. So it is possible to find the values of EDN such that, so it has to satisfy this condition. M power ED is equals to M mod N. So we need to choose the plain text which is less than N. And it is relatively easy to calculate M power E and C power D for all values. M is less than N. So one should calculate the, for encryption. For encryption, we need to calculate M power E. Isn't it? For encryption, we need to calculate this because plain text should be converted. For decryption, we need to calculate C power D. Okay. And it is infeasible to determine D given E and N values because E and D is congruently equivalent to 1 mod phi of N. We need to calculate. So we need to calculate the D value using the formula. Okay, so before going to discuss this, we'll go with some example, RSA example. So is it clear, all of you? Tell me. So is it clear, the procedure of RSA? Okay, first we'll go with some example. Suppose if Bob wants to, Alice and Bob is there. So suppose if Alice wants to send some message to Bob. So what is the first step? Bob has to create public and private keys. So for that, Bob has to select two prime numbers. So here we'll go with some example. So first step, so before going to encrypt the message, Bob is creating the keys, public and private keys. For that, Bob is selecting two prime numbers, that is P is equals to 7. P is equals to 7. P is equals to 7. So what is the second step? Second step is Bob should calculate product of P and Q. N is equals to P into Q. Tell me, what is the N value? If P is equals to 7 and Q is equals to 17, what is the N value? What is N value? Give your answer in chat box. Okay, good. So 119 is the n value. Then third step is one should calculate that phi of n, that is p minus 1 into q minus 1. That is 6 into 16. 6 into 16. Value is 96. Okay, phi of n is 96. So this is the third step. And the fourth step is, what is the fourth step? So fourth step is, Bob should select E value. So where GCD of E comma phi of n should equals to 1. So whichever the value satisfies that. Okay. So what is phi of n? That is GCD of E comma phi of n is 96 is equals to 1. So we need to select, Bob need to select one key, that is E. E is nothing but public key. Okay, so where the GCD of E and phi of n should be 1. Okay, suppose if E is equals to 5, then GCD of 5 comma 96 will be 1. So here E value is 5. E value will be 5, so that the GCD of 5 and 96 will be 1. And then this is the fourth step. And the fifth step is, so E into D is congruently equivalent to 1 mod phi of n. So already E value is 5. So 5D is congruently equivalent to 1 mod 96. So what will be the D value? For which D value this satisfies. Suppose if we take D value as 1, D value as 1. So 5 is congruently equivalent to 1 mod 96. Is it true? Not true, right? Suppose if we take D value 2, so 5 to 10. So like that, the remainder should be 1. Product of 5 into D is congruently equivalent to 1 mod 96. 1 mod 96. So here the satisfied D value will be 77. Okay, 77 is the D value. So E is the selected value 5 and D is the calculated value, where E into D is equals, D is congruently equivalent to 1 mod 96. So the D value is 77. D value is 77. So 77 into 5 is 385. So which is nothing but 4 into 96 plus 1. So the remainder is 1. So after completing these 5 steps, so P value is, P is and Q value, then N phi of n value, then E value, D value. So P is prime number 7, Q is 17 and N is 119, phi of n is 96 and E is 5, D is 77. D is 77. Then, so this is the set of key values. So in this, E is called as the public key. E is the public key and D is the private key. D is the private key. Now, so encryption. Alice has to perform the encryption. So how the encryption will be done? So encryption will be done. The formula is C is equals to m power e mod n is the formula for encryption. So first of all, message should be selected. Once it has a message, once the sender has a message, then only one can encrypt the message. So this m value is less than n. So Alice should select that m value should be less than n. Okay, m value should be less than n. What is n? N is 119. Okay, so you can select any value which is less than n. Not only less than n, which is equal GCD of m comma n is equal to 1. Suppose if m is 19, okay, if the message is 19, then the corresponding ciphertext for this message m is, so how can we calculate? Simply c is equals to 19 power e. Simply substitute. Okay, substitute in this formula. So 19 power e, that is 5 mod n. N is 119. So c is equals to 19 power 5 mod 119. Then the c value will be 66. By simplifying this 19 power 5 mod 119, we'll get c is equals to 66. So this 66 is the ciphertext. So these will be transmitted over the network from Alice to Bob, isn't it? So 66 will be transmitted over the network. So now Bob has to decrypt the message 66. So Bob will get the message 19. Now we'll see the decryption procedure. So decryption. So what is the formula for decryption? M is equals to C power D mod N. So what is D? D is the private key of Bob. So now we know what is C value. C is nothing but ciphertext, that is 66. So 66 power, what is D value? So we have calculated from step 5, isn't it? That is D is equals to 77 mod 119. So if we simplify 66 power 77 mod 119, we'll get the result. We'll get the result 19, which is M. Okay, which is M. So like this, decryption will be performed in the RSA. Understood? So this is the procedure of encryption and decryption. So there is only one formula for encryption, that is C is equals to M power E mod N. And for decryption, M is equals to C power D mod N. But before performing the encryption or decryption, so we need to calculate D value. And first of all, we have to choose two prime numbers P and Q, then calculate the product of prime numbers, then calculate pi of n, which is P minus 1 into Q minus 1. Then select an integer e such that GCD of e comma phi of n should be 1. And then calculate d value, where e into d is congruently equivalent to 1 mod phi of n. So this is the procedure of RSA. Yes, if we go with a step-by-step procedure again, point-wise. So GCD of, so this is the proof for the RSA, that is, here we are going to take two prime numbers and the product of two prime numbers, and then we are going to calculate the Euler's torsion function, that is phi of n value and all. Okay. And we are going to, whatever the message we are going to choose, that message value should be less than the product of two prime numbers, and the GCD of two prime numbers should be 1. Okay. So if we, this is not, yes. So first of all, it should select two prime numbers and calculate the product. Okay, so P and Q are the private and N is the public values already we discussed that P, Q and D are the private, and N comma E, among these 5 values N comma E are the public and these 3 are the private values. Then so GCD of E comma phi of N should be 1. So in that manner we need to choose the E value. E value is the chosen value, and so D value is a calculated value. How can we calculate? D is congruently equivalent to inverse of E, that is E into D. So this is same as E into D is equals to 1 mod phi of N. 1 mod phi of N. So the private key consists of D and the public key consists of these two things. And so user A has published his public key and B wishes to send a message. So B, here B, the person Bob would like to send message to A. Then A has to create the keys like public key and the private key. Okay, the one who wants to send the message will not create any key, but the one who wants to receive the message has to send. Before going to receive the message, first the person has to send the public key so that the sender can encrypt the message and can transmit the ciphertext over the network. So here this is the whatever we discussed till now, the example. So first we need to select 2 prime numbers, calculate the product, and then calculate the phi of N value, and then select one integer E, so which satisfies this condition, GCD of phi of N comma E is equals to 1, then calculate D, so where this condition should be satisfied, and public key is E comma N, private is D only, N is public. And encryption procedure, simply C is equals to M power E mod N. And for decryption, the formula is M is equals to C power D mod N. So this is the same example, till now we discussed. If P is equals to 7, Q is equals to 17, the product is 119 and the phi of N is 96. And we can select the E value as 5, and by determining the D value, so which satisfies the D value, that is 77. Okay. And so the keys, what is a public key and what is a private key? So public key is E comma N. So this is E and this is N, and the private key is D. Okay. So finally, after applying the formulas, ciphertext will be converted to the plain text at the receiver side. But the thing is it possible to calculate 66 power 77 value? So it is the computational